and he engulfs this right here. This is a big old monocyte right here. You get a different colored chalk right here from the monocyte. I'll make him purple. I'll make it red. What do we got there? Red will make him purple, right? So, along comes a big old monocyte right here. Big old monocyte. Oh, hell, you can't see that. Making green. Sorry about that. I'll make him something that you can see anyway. Along comes a monocyte. And he goes to the LDLs. Okay? Now, he engulfs the lipid deposits that are on it right there. But he doesn't get rid of the receptors right there. So more lipid deposits right there. More monocytes come to the area. And these things get so numerous that they invade this tunica interna right here. They invade the tunica interna right here. And they swell it up so large. Now these suckers are called foam cells in there. They get so fat on lipids, so full of lipids, so full of cholesterol, the monocytes do, that they're called foam cells. Now, the outside is not going to expand, alrighty? Not very much at all. It will when the pressure changes, but we're not talking about pressure changes right here. We're talking about something building up on the inside of an artery or arteriole right here, okay? Inside of an artery or arteriole right here. Because it cannot push out this way. Because of the connective tissue, the adventitious tissue that's on the outside of the darn thing. So it builds up on the inside. Builds up on the inside, on the inside, on the inside right there. And that damn thing can occlude that artery or arteriole, okay? So what I want you to get out of this is define arteriosclerosis is plaque formation, focal calcification, and atherosclerosis. All right, that's just by definition right here. Now, plaque formation is due to the engulfing of the lipids on the LDL receptors by the monocytes. That's what I want you to get out of this, okay? Now, and you see a section of coronary arteries are you listed some coronary arteries for me the other day, all right? The arteries that supply the blood flow to the heart, the arteries that come off the base of the aorta right there. There are arterioles, or small arteries right there, okay? So they get plaque formation. You got to do bypass surgery to alleviate the buildup, the blockage of the blood flow to the heart. Otherwise, you got a heart attack coming on, okay? Now, you got some 21-3 plaque within an artery right there, okay? And it's scary. It really, really does. All right, now, monocytes of plaque, we just did the two types of capillaries. Two types of capillaries are continuous and fenestrated. Continuous and fenestrated. Fenestrated is, fenestra is French for window. They got holes in them, they got spaces in between them, okay? So they're leaky, these fenestrated capillaries. Most of our capillaries are continuous. Most of our capillaries are continuous. Let me show you that. All right. Now, most of these suckers are continuous. But that I mean these basal membranes, these membranes right here, are almost locked together right here. Now, there are places in our body where we have holes in them, where we have spaces in between the capillaries themselves. The choroid plexus is one where the CSF is produced, the cerebrospinal fluid is produced, okay? I won't ask you where that is, but the choroid plexus has fenestrated capillaries. The pituitary gland has fenestrated capillaries, okay? And there's some others listed right there. I'd like for you to tell me a location for the fenestrated. I gave you two, give you one back right there. Continuous, the rest of the body. That's all I want. The rest of the body, the main part of the capillaries in the body are continuous capillaries, okay? Now what that means is, when we're talking about capillary perfusion right here, is that it can highly regulate what goes in and comes out of it. What is allowed to leak out was allowed to come back in because there's not that many daggone spaces in between them, okay? They got to go through the cell membrane itself, okay? Sinusoids. Now, I may differ a little bit in what our author has right here. A sinusoid to me is an enlarged blood vessel. An enlarged blood vessels, an enlarged capillaries, okay? Enlarged capillaries. We have them in the spleen, we have them in the liver, and in the bone marrow. So give me two of those. Now what this means is, What this means is, let me show you this right here. Oh hell, this is a better diagram right here. Picture our room right here as a sinusoid. Picture the blood vessel supplying the blood to this sinusoid being the hallway out there. With the door open, the blood comes in and it slows down in this sinusoid right here. Aligning the walls of the sinusoids are big monocytes, big phagocytic cells that we have right here. The macrophages, all right? And they are going to engulf any abnormal red blood cell in the sinusoids, okay? They're standing back against the wall right here, little bitty red blood cell, you're all right, you're all right, oh, you're all right, you're all right, you're all right. Oop, something wrong with you. Well, maybe not quite that quick right there, but they engulf all the red blood cells. Remember, we make 1 million at 1.3 seconds. Therefore, we got to remove 1 million at 1.3 seconds. Otherwise, our blood would sludge, our Pax volume would go up. So, sinusoids are in large blood vessels right there, bone marrow and spleen right there. They slow down the flow of the blood for mainly the removal of the red blood cells, okay, by the phagocytic cells, the monocytes, or the macrophages. That's what I want in your answer. Okay? Precapillary sphincter, then I'm going to take a little break. All right? We have on figure 21-5, I trust it's the same thing right here, the organization of the capillary bed, 715, probably 735 in your book. So turn to 21-5 if you will. Let's talk about the connection between an arteriole and a veniole. In other words, the capillary bed itself. Not the diagram as far as capillary perfusion, not yet. So you'll have to wait a few minutes on that one right there. All right? What the hell am I picking that up for? All right. Arteriole, veniole. All right? Now there's a connection between a capillary, there's a connection, the capillary is a connection between the arteriole and the veniole. I'll get you out here, just be patient with me, all right? You have been so far, no need to give up on me right now. Now some of these capillaries right here are thoroughfares, right? And we have a thoroughfare, that's hard for me to say right there. We have an anastomosis, that means there's a direct connection between the darn things. There's a direct connection between this right here. An anastomosis, an AV, arterial venial anastomosis. I want you to learn the word anastomosis. It's just a connection. It's all that it is between an arteriole and a venial, an AV anastomosis. A-V-A-N-A-S-T-O-M-O-S-I-S. God, that sucks. I'm glad it's written in that in the book. An AV anastomosis. Now, why would we have a direct connection between an arteriole and a venial? Why would we bypass all the cells that these capillaries need to feed, all these thousands of cells that are only about 1 or 2 cell layers away from a capillary? Why would we want to bypass them? Well, the answer is simple. To maintain venous return. To maintain the flow of blood. Not to slow it down, at all, but to maintain the amount of fluid getting back to the heart, the venous return itself. Right? Flow of blood, flow of blood, flow of blood, flow of blood, flow of blood. So the benefit of an AV anastomosis is to maintain venous return, which, take a look at your notes, you just wrote it down, maintains cardiac output. Without blood going in, you have no cardiac output, or your cardiac output is greatly diminished. We've got to keep that up. So an AV anastomosis maintains venous return, which maintains cardiac output. I need for that concept to sink in right here. So what I'm asking you here about the sphincters themselves right here, okay? The capillary thoroughfare still is a connection between an arteriole and a venial right there to maintain venous return. Now, the rest of the capillary network right here, has sphincters on it. On precap sphincters. And I ain't going to draw that mess right there because you got it right there in your book right there. Well, the reason that you have to have a precap sphincter is we don't have enough blood in our body to fill up our capillary bed. What? Well, that's true. I just thought I'd ask myself that question. We do not have enough blood in our body to fill up all of our capillaries at one time. If we did, we would go into shock. We would have no venous return, our heart rate would go out the roof, and we would die. Okay, with that in mind, the way that we regulate this is a precap sphincter. About once every oh, let's see, about every 6 seconds. About every 6 seconds, the precapillary sphincter will open. That means the other 54 seconds, the damn thing is closed. All right? So it opens and it closes, it opens and it closes, all right? So about 6 seconds out of a minute, 6 to 8 seconds, somewhere. I don't really know about the timing. I really have forgotten that. I was trying to think about 1/6 of the time the darn thing is open, which would put it around every 10 seconds, I guess. That makes sense. About every 10 seconds. So about 1/6 of the time the capillary sphincter is open. The other 5/6 of the time the capillary sphincter is closed. So they're open and they're closed, they're open and they're closed. So mainly they're closed right there. The regulation is important as far as the blood flow through the capillaries, because we do not have enough blood to fill up all of our capillaries. We have to open them, then we have to close them. We have to open them, and then we close them. And that is the role, the function of the precap sphincter themselves, okay? Now, okay, I'll touch on collateral arteries. Then we'll take a break. Collateral arteries are an alternate blood supply to an organ. Collateral arteries are an alternate blood supply to an organ, all right? Blood flow to the base of the brain has collateral arteries, okay? The blood flow to the uterus has collateral arteries. Those are the two main topics or locations that come to my mind right there. You have a main artery, then you have a collateral artery, okay? You have a main artery, then you have a collateral artery. But it supplies, it's a substitute source of blood for an organ. That's not a bad definition for a collateral artery, okay? Okay, we'll take a break. I'll pick up with vasal motion and get down to about viscosity, and that'll be it for today. Alrighty, see you shortly.